Unlocking Digital Memory, an introduction to registers. Welcome to this exploration of digital registers, fundamental building blocks in computing and digital electronics. Understanding registers is key to grasping how data is stored, manipulated, and moved within digital systems. Today's agenda: what we'll cover. 01. 02. The fundamentals of registers. Shift register basics. Understanding the concept of data shifting. Defining what registers are and their core purpose. 03. 04. SISO. Serial in, serial out. SIPO. Serial in, parallel out. Exploring a simple shift register configuration. How serial data can be converted to parallel. 05. 06. PISO. Parallel in, serial out. PIPO. Parallel in, parallel out. Converting parallel data streams to serial. Simultaneous data loading and output. 07. 08. Universal shift registers. Key takeaways and applications. The versatile all-in-one register solution. Summarizing core concepts and real-world uses. Registers defined. Digital memory fundamentals. A register is a collection of flip-flops, typically D flip-flops, used to store binary data. Each flip-flop in the register stores one bit of data. An n-bit register consists of n flip-flops, capable of storing n bits of binary information. They are essential for temporary data storage and manipulation in CPUs and other digital circuits. Unlike individual flip-flops, registers are designed for collective data operations, making them highly efficient for tasks like counting, shifting, and data transfer. Shift registers. The art of data movement. Shift registers are a type of digital circuit that allow for the shifting of data bits, one position at a time, in a sequential manner. This sequential movement is crucial for operations like serial communication, data conversion, and specific arithmetic functions. Serial in, serial out, SISO. Serial in, parallel out, SIPO. Data enters one bit at a time and exits one bit at a time. Serial data is converted into a parallel output. Parallel in, serial out, PISO. Parallel in, parallel out, PIPO. Parallel data is converted into a serial output. Data loads and exits simultaneously in parallel. SISO register. Serial in, serial out. In a SISO register, data is entered serially, one bit at a time, into the first flip-flop, and then shifted through subsequent flip-flops with each clock pulse. The data also exits serially from the last flip-flop. This configuration is ideal for applications where data needs to be delayed by a specific number of clock cycles or for simple serial data transmission over short distances. SIPO register. Serial in, parallel out. The SIPO register takes data in serially, one bit at a time, just like the SISO. However, once all bits are loaded, the entire word can be read out simultaneously in parallel. This is incredibly useful for serial to parallel conversion, often found in communication systems where data is transmitted serially to save wires, but then needs to be processed in parallel. PISO register. Parallel in, serial out. Conversely, a PISO register allows data to be loaded in parallel, all bits simultaneously, and then shifted out serially, one bit at a time. This is the core of parallel to serial conversion, essential for transmitting wide data words over a single communication line, saving bandwidth and cabling. Think of converting an 8-bit byte into a stream of 8 individual bits for transmission. PIPO register. Parallel in, parallel out. The PIPO register is the simplest type in terms of data flow. Data is loaded into all flip-flops simultaneously in parallel, and it is also available for output simultaneously in parallel. These registers are primarily used for temporary storage of data words where no shifting is required, such as holding data before it's sent to an ALU or memory block. They act as a direct buffer. The master of versatility. Universal shift registers. A universal shift register is a highly versatile component that can perform all the operations of the basic shift registers, SISO, SIPO, PISO, PIPO, and often includes additional functions like hold, clear, and load. Serial in, parallel in. Data can be entered bit by bit. All bits can be loaded at once. Serial out, shift right. Data exits bit by bit. Data moves towards the right. Parallel out, shift left. Data available simultaneously. Data moves towards the left. Their flexibility makes them indispensable in complex digital systems where various data manipulation capabilities are needed within a single device. Summary and applications. Key takeaways and beyond. Registers are the unsung heroes of digital systems, enabling data flow, storage, and conversion. SISO. Simple delay and serial data transfer. SIPO. Essential for serial to parallel data conversion, e.g., UART receivers. PISO. Crucial for parallel to serial data conversion, e.g., UART transmitters. PIPO. Basic temporary data storage, buffering. Universal registers. Versatile multifunction data handlers. Where you'll find them: data processing, digital communications, memory and peripherals. CPU accumulators, program counters, and instruction registers heavily rely on these principles for efficient data handling. From Ethernet to USB, registers facilitate the conversion of data between serial and parallel forms for transmission and reception. Used in memory addressing, keyboard input, and display drivers for temporary storage and data alignment.